All right, good morning and welcome to this week's edition of Virtual Breakfast. For those who don't know me, my name is Jenna Thaler and I'm a field crops educator over in the Thumb. So this morning we have Dr. Kurt Steinke with us. Thank you for joining us, Kurt, and he's going to be talking about nitrogen stabilizers and extenders.
All right. Hopefully everybody can hear me all right this morning. Thanks for being here today. Going to talk a little bit about some nitrogen stabilizers and extenders. Hopefully, I'm going to guess there's going to be a lot of seed bags ripped open here over the next couple of days with the weather hopefully turning. But wanted to touch base a little bit on just some basics of what to consider with stabilizers and extenders. So, the first thing is, why do we consider end stabilizers or extenders? You can ask yourself that question, and a lot of us will come to the answer of nitrogen is unpredictable, right? And you can look back at probably corn end response trials, wheat end response trials, et cetera, over the last 2, 3 years even, and you never find the same optimal N rate year over year, right? So nitrogen is often unpredictable. And I want to start off today a little bit with a quiz question, get your brains cranking here this morning. Looking at weather factors govern what percent of all components of the corn end response process, right? Look at A, B, C, D, and E right there. We looked at this study across 19 states and Canada. Come up with your best guess, and the answer would be about 75%, right? So about 75% of the corn end response process is governed by the weather. Now, to think about that in a different term, what percent of variability in corn economic optimal end rates is caused by weather? Same study, same 19 states, couple Canadian provinces, almost 500 site years. Look at A, B, C, D, and E over on the right-hand side of the screen and take a guess. It's about 66, right? So that's amazing in my mind. You're looking at two-thirds to three-quarters of that corn end response process is governed by the weather. And so we have to account for the weather. We have to account for some of the weather unpredictability that we now deal with on a little bit more frequent basis. So I put this together. A lot of you may have seen this over the winter. I talked about this quite a bit. I just have about the last 6 growing seasons up on the screen, looking at about the Lansing area, looking at precipitation patterns. And you can look at some of that variability, right? So that red circle that you see on each year is that dry pocket, right? And so it's that dry pocket, that 4 to 6, 4 to 8 week window where we just don't get timely rainfall, right? And you can look at just the last 6 years. It might come late in the season, like last year, might come early in the season, like we saw in 23, 2022 came in the middle, and then 19, 20, and 21 down at the bottom, you can see when it popped up on that screen. That's just the dry pocket. Combine that with maybe in 2023 early, we had significant moisture. 22 was pretty wet early in the season. 21 was pretty wet mid-season, right? So it's a little bit unpredictable. You can look at April, May, and June. I update this chart every year, and you can look at April, May, and June for about the last, what I got on there, about 19 or so years. And, your chances of being greater than 33% below normal, greater than 33% above normal, or within those ranges are pretty equal. About half the time will be normal. About a quarter of the time, you're going to be excessively dry, and about a quarter of the time, you're going to be excessively wet, right? So, especially for our corn and wheat acres and your nitrogen applications, this becomes a real issue. And when you start talking about nitrogen and the nitrification process, what does weather impact? Well, look at the last 2 seasons. I talked about this slide a little bit over some of the winter meetings also. So we had a study out looking at nitrate and ammonium dynamics, or basically nitrification rates over time the last 2 seasons. And at the bottom of your screen, you can see pre-plant urea applied in 2023 and pre-plant urea applied in 2024. And we took soil samples at 2, 4, 6, and 8 weeks after application. And you can see that ammonium to nitrate conversion. And then that third column is that ammonium to nitrate percentage. So if you go back to 2023, remember it was really dry, that April 6th to July 1st period. And so nitrification was a little bit stalled out, as evidenced by that ammonium concentration stuck around until about 8 weeks after application. And that really impacted your nitrogen performance on specifically your corn acres. Now you look at 2024, the bottom part of that table, we started nitrifying really early last year, right? It was warm early. We got in the ground earlier. It was wet earlier. And so nitrification got kicked off to a jump start or a quick start, and we nitrified quite early in the season. So just looking at those percentages, even with almost a similar planting date, look at 2, 4, and 6 weeks after application, we had a lot more ammonium in 2023 than we did 2024. So yes, there can be variability in your nitrogen performance. Now, nitrogen inhibitors or extenders, what are they? They're basically products or chemicals, substances that we add to conventional end sources, typically anhydrous ammonia, urea, or 28, that increase that end use efficiency by controlling that end release. So which category you choose depends on which end loss mechanism you're targeting. So if you're more concerned about leaching, remember leaching's that downward movement of water that contains nitrate, moves it out of the root zone. We tend to be a little bit more concerned with leaching on our coarse textured soils, so our sandy soils. Remember that in your medium and fine textured soils, well, we often worry about leaching. Leaching is not a quick process in those finer textured soils. Volatilization might be your primary concern. That's when ammonium converts to ammonia, gets lost as a gas. Our target here is surface applied N that is not incorporated. Right. So if you incorporate your nitrogen into the ground, pre-plant incorporated, maybe injection, etc., volatilization tends to be less of an issue. And then denitrification, right? That's when nitrate converts to N gases and gets lost from the soil. Those are our waterlogged soils. We got standing water, poorly tiled soils. Typically, we have to have standing water, warmer soil temperatures, and you got to have some of that nitrate present. Right. So which category you choose depends on which end loss mechanism you're targeting. So with urease inhibitors, it's a good reminder that urea is an organic compound, right? Has to be hydrolyzed, has to be combined with water and the presence of that urease enzyme to ultimately break down and produce ammonium N. So that first product you see in this reaction on your screen is ammonia gas, right? That's volatile. It takes water to keep ammonium N in place and to move that reaction to the right or keep it moving forward. So when urea combines with water, ammonia can form very quickly. It depends on how much water you receive, whether that ammonia can then transform to ammonium. All right. So typically, if you get about, I'll say about a quarter inch of rain or so, that's usually enough water to keep that process moving along and to keep that end or move that end from the surface down, lowering that soil profile, and that urea molecule can transform from or to ammonia and then to ammonium. Urease inhibitors inhibit that urease enzyme that's ubiquitous or found in all of our soils. So it keeps it from reacting with that urea molecule. All right. It keeps it from binding, and that reduces the conversion rate to ammonium. All right. So again, urease inhibitors are focused on surface applications of N. They're focused on volatile N losses, right, off that soil surface. A couple different types listed in that top bullet point there. NBPT is probably the most prevalent. Those would be a lot of your Agritane products from years past. Another one out there, a couple new chemistries, Duramide and NBPT, and then there's NPPT, NBPT, and NPPT. Those are all examples of urease inhibitors. Some of these are off patent, so there are generic cousins of a lot of these products. And these products provide about 10 to 14 days of protection against ammonia loss. Some of those newer chemistries in that second and third bullet point up above, they may add upwards of about 25% more time. So instead of 10 to 14 days of protection, you're looking at probably maybe about 13 to 17 days of protection, somewhere in that window. In some cases, maybe a little bit longer. So again, those urease inhibitors, you're focused on surface applied urea-based fertilizers. If you're in a high residue system, they might be a benefit. If you're in high surface soil pH and surface supply your N, they might be a benefit. But I want to point out those two pictures on the right-hand side of your screen. That was taken up in the Saginaw Valley. I believe in the summer of 22, there was a lot of surface applied nitrogen, and we hit a dry pocket. And what happened about 2 to 3 weeks after N application? You're looking at volatile N losses on that corn crop right there, right? That's what that volatilization N loss looks like. And so if you get past that window, you can still get some of those volatile N losses to occur. Now, switch gears here a little bit. Nitrification inhibitors, those are a little bit different chemistry. So again, nitrification, biological process, hydrogen gets stripped off of ammonium and oxygen is attached. Those nitrification inhibitors block an enzyme in a nitrifying organism or nitrifying bacteria that stops the formation of nitrite, as you can see in that top equation there. And if you stop the formation of nitrite, you then stop the formation of nitrate, right? And so the whole goal of some of these nitrification inhibitors is to allow that nitrogen to remain in that ammonium N for a longer period of time, right? And that drops or decreases the ability of nitrate to leach or denitrify. How does that happen? You got to remember your charges here, right? Ammonium, positively charged, soils, negatively charged. Think of it as like a paper clip, right? You can paper clip that nitrogen to that soil, can hang around for a longer period of time, versus something like nitrate, negatively charged, soils negatively charged. You tend to get more N losses because of that nitrate sticking around. So a couple examples of nitrification inhibitors, you would want to consider these where you're looking at leaching and or denitrification losses, right? So not volatilization N losses, we're looking at leaching and denitrification. Couple examples listed top of your screen there. Nitropyrin, N-Serve, Instinct. Nitropyrin's been around since I want to say here about the early to mid 60s. So that is not a new product. DCD is another example. Pronitridine is another example. Those are all examples of nitrification inhibitors. You would want to focus these on your heavier textured soils. So not necessarily sandy soils, although you can use those perhaps on some sandy soils, but we tend not to get necessarily denitrification on sandy soils because they drain so readily. But again, it does tackle that leaching component. So where we tend to see these focused a little bit more would be with autumn N application in your I states or with anhydrous ammonia applied in the autumn also. So again, really you want to focus on your poorly drained soils here in the state. You can perhaps use them a little bit on your sandy soils to prevent some of that leaching. One thing you have to consider, however, is your cropping system, your pattern of N uptake, your timing of application, and your weather pattern. Because there's a big difference between wheat N uptake and corn N uptake. Wheat N uptake occurs much earlier in the season, so you may not necessarily want to delay that conversion of ammonium to nitrate because you might miss your window of opportunity for N uptake in that wheat crop. And there are also products out there that are nitrification and urease inhibitors. So they would cover all three forms of N loss. They might have something like DCD and NBPT or NBPT and pronitridine. Again, they will protect against volatilization N losses, leaching N losses, and denitrification N losses. So as I begin to wrap up here, I want to show you some work we did the last couple of years, looking at some of these nitrate and ammonium dynamics or nitrification rates over time. Just put some data up from 2024. These are all at 180 pounds of N, pre-plant incorporated. And that first line you can see on the screen down there was urea, put out PPI. You can look, we took soil samples at 2, 4, 6, and 8 weeks after application. You can see yield potential or yield level over on that right-hand side of the screen. And you can kind of see with urea, what happened last spring, 2 weeks after application, boom, we got nitrification rocking and rolling already, right? It was warm, we had plenty of moisture, optimal conditions. You put your N out, it nitrified quite early. Now, look at this next line is where we use the nitrification inhibitor. Look what happened at 2 weeks after application. right? So we're not necessarily, because of nitrogen dynamics in the soil, we're not comparing numbers in one line versus the other, but it's more about that conversion of ammonium to nitrate. So 2 weeks after application, we had more ammonium than nitrate. You bump that out to 4 weeks after application. That ratio is much more similar. 6 weeks out, boom, you see that nitrification begin to occur. And you get about 8 weeks out, you can see there's a lot more nitrogen available in that soil. Next line down, where we look at a higher percentage of a nitrification inhibitor, all right, with a little different chemistry. Again, you get 2 weeks out, 4 weeks out. See how that concentration's much more skewed towards ammonium than nitrate. And then you get 6 or 8 weeks out, that product is doing exactly what it's supposed to do, right? Prevent that nitrification process from occurring for a set period of time. And then that last line down there, I didn't talk about this much today, but we threw polymer coated urea into the mix. That's a little different chemistry now, right? It's not necessarily a nitrification inhibitor. It basically controls that end release over a longer period of time, right? And so water goes into something like that frill of PCU, and then it slowly bleeds out or slowly gets metered out over time. And those numbers show you it did exactly what it's supposed to do, right? It keeps that end uh, coming out of that frill for a much longer period of time at a much lower rate as compared to something like a nitrification inhibitor. And so, how you get moisture will influence the effectiveness of some of these products. Whether after you apply in, is it one big rainfall or is it a wet period that we get into? It might be 2 to 4 weeks, 2 to 6 weeks of a wet period. These products can perform a little bit differently. So, implications to consider moving forward. Remember, you need N loss conditions to see responses from these products, right? If you do not have N losses, whether they're volatile N losses, leaching N losses, or denitrification losses, if you don't see those, there is no reason to expect to see a response to these products. Urease inhibitors, if you do use those and you get a large rainfall soon after application, you can see yield reductions. So remember, urea is not a charged molecule. And when you use a urease inhibitor, it keeps it in that uncharged state for a longer period of time. So we've actually seen where we use urease inhibitors and you get maybe a 2.5, 3 inch rainfall right after application. You can actually move some of that end a little deeper in the root zone. With nitrification inhibitors, be careful. You do not want to inhibit nitrification too long, right? And this is probably a little bit more aimed at maybe your wheat crop here in the springtime, since we're at that green up stage. You don't want to mistime that N uptake. In your fall end states and elsewhere where you use fall applied N, you still need to wait until soil temperatures drop below 50 degrees to use a nitrification inhibitor. This becomes a big issue. Oftentimes we see with manure applications in the fall. Just because you use a nitrification inhibitor doesn't mean you could go out and apply N before the soil temperature drops below 50 degrees. You still have to wait. And to wrap up here, remember, spring applied N still tends to out yield fall applied N. Last picture I want to show on the screen here is we have a winter wheat project out this year. I took this picture, what is it, about a week ago today. See that those green squares in the middle of this wheat study, that nitrogen was applied about 5 months ago. All right, so we used a little bit of a different chemistry here and kind of a different approach to what we're doing here. Think outside the box a little bit. So I'm not going to say what this is. I'm kind of gonna bait you a little bit here. If you want to find out what that treatment is, Wheat Field Day is coming up June 25th. I'll talk about this study specifically. So if you're interested, stop out that day and we'll go a little bit more into detail. But that end there was applied about 5 months ago. So with that, I'll wrap up. I'll stick on this morning if there's any other questions, but I appreciate your time. Thank you, everyone.
Thank you, everybody, for attending today. Here's just our reminder. You can follow us on X and access all these recordings on Apple Podcasts, Spotify, or follow us on Facebook as well. And they're also posted on our website. And with that, we're going to move on to the Q&A section. And it looks like we have a decent amount for Kurt, but if anybody has anything for Jeff or any more for Kurt, please feel free to drop them in as we go, because we do have about 20 minutes worth of time, and I currently have 4 questions. All right. Kurt, the first one's for you. It says, hi, Kurt, you mentioned environmental components impacting nitrogen availability, but are there environmental factors impacting the effectiveness of the urease or nitrification inhibitors?
Yeah, that's a good question. So the biggest areas of focus would probably be one, if you're in an irrigated system, right? You're in control of the water. And so, something like a urease inhibitor may not be needed because after application, you can put a quarter to a third of an inch out and work that N off the surface into that root zone. If you're probably fertilizing at an already super optimal N rate, um, there probably would be little reason to use one of these products. Um, High pH soils, I kind of mentioned that a little bit. That would be an area where perhaps a urease inhibitor would come into play a little bit more. And I think one of the things you need to think about is your actual the biology of crop and uptake for whatever cropping system you're thinking about here. So, a great example, it's mid-May. A lot of us, if you haven't put N out on wheat yet, you probably will be very, very soon before the wetter weekend comes in. Um, wheat is not corn, right? I always emphasize this. Wheat uptakes or the wheat growth pattern, wheat will put on 40 to 60% of its biomass in about a 3 week window, right? You don't want to miss that window, and it occurs much, much quicker than something like corn does. And so, there is a risk with using something like a nitrification inhibitor at this point of or this time of year on something like wheat that you can inhibit that transformation of end a little bit too long, and then you miss your end uptake window, right? Versus something like corn, maybe you go out with a pre-plant broadcast, PPI, weed and feed method, something like that. You're still not going to hit that peak corn and uptake period for another 4 to 6 weeks, best case, right? So again, a little bit of a different scenario there, where you would want to maybe consider using one versus the other.
Thank you. The next one, were the yield differences significant in the ammonium and nitrification study that you showed from last year?
That was a great question. So the four uh, products I had on the screen there. No, those yields, I think they range from anywhere from about 175 up to about 186 or so, were not significant. And so last year, what was interesting at this specific location, we were consistently moist, but we were not excessively wet, right? And so you can look across the state. There were areas where we had drain tile flowing all summer long, but in a lot of those areas, we did not get a 4, 5, 6 inch rain, right? We just got consistent half inch to an inch, some cases maybe an inch and a half of moisture on these consistent intervals. So we didn't, we had some land loss conditions, but we were never in most areas of the state, we were never saturated with standing water. Right. And so that was the big difference. We saw some differences in how these products functioned, absolutely, and a lot of these products functioned like they were supposed to. But we were not in a scenario at that specific location where we saw a positive response to these products at that location in 2024.
Fantastic. The next one is how would you comment on how these programs fit into the 45Z incentivizing programs or similar programs?
All right, I'm guessing, let's see here, my memory's fuzzy this morning, but I'm guessing the 45Z programs probably deal with maybe a little bit more on sustainability, carbon emissions, greenhouse gas emissions, things like that. I believe there are government cost share programs in place for using some of these products. I would probably contact your local NRCS professional. They have a much better idea. I know in the past there has been some cost share to using these products. But one thing you have to remember, even with something like nitrification inhibitors, polymer-coated urea, in many cases, we just delay some of those greenhouse gas emissions, right? So instead of getting maybe a plume soon after planting with soluble N, you might get some of those emissions maybe 4 to 6 weeks later. So it kind of offsets it, right? But again, it doesn't necessarily mean um, these products aren't doing what they're supposed to do. They work in specific scenarios, specific functions, but I would probably contact your local NRCS professional because some of these products have cost share and some do not.
Fantastic. And James, if it's a different 45Z program, let us know. Uh, we can circle back around. So Gordon had a question. Does ammonium thiosulfate have any effect on inhibiting nitrogen volatilization of UAN? And have you done or seen any tests with respects to this question?
Yep, so that's another good question. ATS, ammonium thiosulfate, has some nitrification inhibitor properties. Um, the mode of action of how that occurs is still not very well understood. But from a nitrification inhibitor standpoint, it does have some of those inhibitory properties. The issue with ATS is to get that, you have to use it at extremely high rates, right? So probably rates that might be beyond what you need for maybe a sulfur application on your crop of interest. But I will say there are some nitrification inhibitor properties to ATS, but you have to use it at probably rates higher than what you would normally use ATS for.
Now, and I don't know if you look into that, follow up to that. If you're applying at higher rates than normal, is there an economic return that's been seen to that?
So that depends how you're using it, cropping system, et cetera, right? So most of us will probably use ATS a little bit more for a sulfur application, right? And so there you're looking at probably anywhere between about 15 to 25 units of S. So that could be, do my math, probably 5 to 7, 5 to 8 gallons per acre, something of ATS. So it might have to be, at rates at that or above to get some of those inhibitory properties. Where we typically tend to see more of that ATS use would be again with your starter fertilizer, your 2x2 application to give it a little quick dose of that NNS early in the season.
So Leanne says we plant sweet corn weekly from mid-May to early July. We typically use some urea in mid-May and then side dress with UAN. Our soil is medium to heavy topsoil over clay subsoil. Would an inhibitor in the urea likely be valuable?
So that becomes a tough pocket window there, right? When you got these staggered plantings of sweet corn from mid-May and on, you get some of those very difficult conditions. You start looking at soil conditions, weather conditions, mid-May to maybe that mid-June window. You can deal with crusting if it dries out. So yeah, that could be something to consider. If you're irrigated, right? Many sweet corn operations are, then you're in control of the water source, so you can control that volatilization potential, right? If you're maybe heavier textured soil, but drained well, whether that's due to topography or slope, then maybe denitrification is not as big of an issue. So remember, with denitrification, you got to have that standing water and you got to have those warmer soil and air temperatures, right? Can you denitrify in your shoulder seasons? Let's say spring and fall. Absolutely. It just occurs at a much slower rate because the soils aren't warm enough. But you start getting into that window where you get standing water and you get soil temperatures that are probably getting into that 72 to 75-degree range. That's when peak denitrification can occur. You start getting maybe soil temperatures down those upper 60s. Denitrification does not occur nearly as quickly. Does it occur? Yes, it's just not as quick. So the magnitude of losses aren't as great.
Thank you. Okay, for the second, that's the questions we have. So please continue to drop any more questions you have in the chat. And we have a number of specialists on, and as one of the few growing crops we have out there right now is wheat. Dennis, I think I saw you were on. Do you have an update?
Um, so the GDD accumulation or the departure from normal, Jeff, that chart or that graphic that you had there, it really is. I can see that in the wheat in the field. We've got wheat in the southern part of the state that is approaching 5. Uh, but then there's other places where it's still in that 3 to 4 range. So we're seeing a little bit of disease out there, some snow mold. I still get pictures sent of that. We're starting to see a little bit of powdery mildew show up in places. But with that wheat growth moving toward in the southern part toward that Feek 6, remember that's a cutoff for some of the herbicides as far as the timing of application. So um, don't discount your wheat. Get out there and look, see where you're at on growth stages, because if you got herbicide to get out yet, make sure you're getting it out on time.
Dennis, we have a follow-up question. Can you talk about how to confirm snow mold damage?
Yeah, so snow mold, Actually, if I could share my screen, I can show you what snow mold looks like. Okay, so here's this would be speckled snow mold, and this is a close-up of leaves. And notice the kind of dark necrotic tissue here. Eventually, these leaves just kind of senesce and die off. This is one of the snow molds that I'm seeing out in the field. In bad scenarios, it can look like this. And what happens in the field is this stuff this got an early snowfall with warm soil temperatures. And snowfall remained on the field for a long period of time, which insulated it and kept the soil warm, which allows the disease to infect the plants. But you see this kind of matted um, scenario where the leaves are laying right flat on the surface. And so, I talked to this grower in this area of the field, he's going to just tear up. But that this is kind of what it sort of looks like. I can show you a couple of other pictures. This is a close up of some of the dead material laying there, and you can notice this kind of like almost like dark greenish hue to it. That's the residue or the mycelia of the fungus. And by now this is pretty well dead here. Now the even the fungus is no longer alive on that plant tissue, but that's some of the diagnostics of what to look for.
All right. Thank you, Dennis. Oh, another follow-up for you. Do you know if there can be varietal differences in wheat tolerance to snow mold?
So when you look at the compendium of wheat diseases put out by the American Phytopathological Society, they say one of the management tools is plant resistant varieties. However, most seed companies don't know what varieties have what level of snow mold resistance because this isn't a frequent disease problem. And so screening for this is we just don't do it around in this part of the country. So yeah, that is one of the things they say to look at, but we don't have any good data to say, you know, this variety has a different score than this variety.
Thank you. Now I see we have other specialists on, like Marty and whatnot. Chris, does anybody have any updates?
I don't have an update, but I will say that if you are in southern Michigan, given the degree days, Jeff already showed there are some degree day accumulations. Seed corn maggots wake up early. Their temperature base is 39 degrees, not 50. So if you're, going to put something in the ground soon and you've plowed green stuff up, I would check that EnviroWeather model. Seed corn maggot will appear under corn. So if you're about to plant beans, you might want to look at that and check to see if you're at peak flight or not. I can't get into that website right now, so I can't access EnviroWeather, but if you can, that would be a good idea, I think.
Nicole says the Constantine station is showing peak flight for tomorrow.
Okay, that's a couple days ahead of last year, which was like the 13th. So yeah, no, it was like the 22nd. So yeah, thanks for checking that for me.
Any updates from any of our other specialists? All right, hearing none. This was your last call. I'm going to go ahead and thank Jeff and Kurt for joining us this morning. We really do appreciate you, and thank you all for attending, and we will see you next Thursday.